Kia ora koutou, Reese from QuickSense here, and today we're looking at parallel lines. Now, this question is asking which of the following equations is parallel to a line with gradient 3, right? And what that looks like is y equals 3x plus c. And something that is parallel will have the same value of m. Right? So regardless of where they start, what c is, they're never going to get closer or further away to each other because their slopes are the same. They are parallel to each other. So what I need to do is turn each of these equations into the form y equals mx plus c, and I'm looking for one that has 3x. So this first one here, I divide both sides by 3, giving me 1/3 x plus 4 over 3. Rolling that one out. This next one I divide both sides by 2, 3 over 2x plus 3. We can rule that one out. And I can actually, seeing it already, I can rule out this one. Right? It's already in the right form, and 1 is not 3. So let's have a look at this last one. Divide everything by 2. 6 over 2 is 3x plus 2, 4 over 2. So we can see this equation is parallel because the coefficient of x is the same. They both have m equal to 3. In this next question, we're given two equations and two pieces of information that are going to help us answer this question. So first of all, I need both of these equations to be in the form y equals mx plus c, where m is the gradient and c is my y-intercept, or the constant. So how do I do that? Well, for this first one, for a, right, we have 4y equal to I'm going to divide both sides by 4. Okay, and using what we know about fractions, right, I can actually see that this is equivalent to, well, becomes y, this becomes a plus 3 over 4, lots of x, plus 12 over 4, which is 3b. All right, we can do that for our next one. If you're confused as to what's going on there, I would suggest going back and having a look at lessons on fractions and adding fractions with the same denominator. So our next one, same thing, 4y. We're going to divide that by 4, but what are we dividing by 4? b minus 2x minus a. So we divide these by 4, giving me we could write that as take away a quarter a. So what do I know? Well, I know that they're parallel. So what does that mean? Well, that means that this first m is equal to this second m. So let's run this simultaneous equations. Let's set them to be equal to each other. A plus 3 over 4 equal to b minus 2 over 4. I times both sides by 4, giving me a plus 3 equal to b minus 2. Let's just see what a is. Right, a is equal to minus 3 from both sides, b minus 5. Okay, helpful. But let's have a look at the second piece of information that's really helpful. The y-intercept of line A is 3 times the y-intercept of line B. Okay, well, what's the y-intercept? The y-intercept of line A and the y-intercept of line B. Okay. So line A, 3b, is equal to 3 lots of the y-intercept for line B. Okay, well, I'm going to divide both sides by 3. Oh, sorry, I've missed a... Oh. I'm going to divide both sides by 3, giving me b equal to negative a over 4. Now here's where I want to either rearrange this so that it is a equals, or rearrange my initial one so that it is b equals, which is what I'm going to do. Just makes it a little bit easier. So I add 5 to both sides over here, giving me a plus 5. Well, if that's true, a plus 5 is equal to negative a over 4. Then I timed everything on the left-hand side by 4, giving me 4a and 5 times 4, 20, equal to negative a. I am going to add a to both sides and subtract 20, giving me 5a on this side and negative 20 on this side. Divide 5. A is equal to negative 4. If a is equal to negative 4, then b is equal to negative 4 plus 5, which is equal to 1. And this will finally allow me to determine what my gradient is, right? Because both m's are the same. Let's use a. So that m is equal to a plus 3 over 4, which is equal to, a is negative 4, so negative 4 plus 3 over 4 equal to negative 1 over 4. Now you can check this with b minus 2 over 4 and see if it works, but for our purposes, we are done. The gradient of each line is negative 1 over 4.